All right, so this is going to be a review of everything that we have covered so far in heredity. So the first type of heredity we did was something called a monohybrid cross. So this is when we had a dominant trait represented by a capital letter, and we had a recessive trait represented by a lowercase letter. So we use this when we have one trait that we're looking at that's either dominant or recessive. So for example, if we had eye color and we had blue eyes and we had brown eyes, we could use still the B. This is the dominant trait, and it was big B and a little b, and a recessive one was two little b's. And if we did a cross, I'm going to do mine just right up here. If we did a cross and we had somebody with, oh, that's going to be really tiny. Hold on, let me get rid of these. Alright, so if I did a cross, and I had a big B and a big B, and someone who was heterozygous. So we could use those terms too in here. You could write those on here. This is homozygous. And this one right here is heterozygous. Now make sure you're filling this neatly on your page because I'm working off my iPad. I can't write really well with my finger, but you'd be containing this all within this area right here, within that top spot, because we're going to be filling out the bottom ones too. Okay, so we've got homozygous, heterozygous. These are genotypes. You could include that information on here too. You could also say that they're alleles. This is kind of essentially like a note card that I'm letting you use for Wednesday. All right, so once we have these, we can go ahead and create our end result here. Again, I'm working with my finger, so this isn't perfect. But we would have all of these coding for brown eyes. Nope, just kidding. All of these coding for brown eyes, and we wouldn't have any coding for blue eyes. So this would be 100% brown eyes. Now, if they were asking you what percent is heterozygous, 50% would be heterozygous, 50% would be homozygous. So that was a monohybrid cross. That's where we started first, and we kept things pretty simple. A dominant and recessive trait. And then we looked into something called incomplete dominance. In incomplete dominance, we were dealing with only dominant alleles. So that's one specific difference from above. And what we ended up with was a new trait. So let's look at an example of this. If I have a little flower here, it's going to be my other little flower. One is red, and let's just give it, we'll do bees. And the other one is blue. This is going to be very reminiscent of your, I know, not making any sense. We're just going with random letters. If you don't like that, if you wanted to keep it, which would have made more sense in the color scheme world, you could have done this. If that makes you happy, then awesome. Okay, so we got red flowers, blue flowers. Again, letters are completely negligible. Doesn't matter what you use. So everything is caps because it's codominance. If we're going to complete a Punnett square, which I'm going to do up here, if I were to cross two red flowers with two blue flowers, as you can see, everything is going to be BR. within these boxes, which is going to code for, wait for it, a new trait. And our flower is going to be, ooh, it is not going to be brown. This is not the color I wanted. There we go. It is going to be purple. So BR, or the heterozygous situation in codominant, or incomplete dominant, excuse me, gives us a new trait, which is going to be purple. So this one resulted in a new phenotype. In this case, that phenotype is a purple flower. Okay, so then we had codominance. Codominance, we still have all dominant letters still. Initially, blood typing was a little bit more advanced, and I have that blood types are on here because codominance was an example of that, but I'm going to do a simple version of codominance where I'm not throwing in that recessive O. So we've got all of them are dominant, and we get both traits present. So in this situation, if we use the same one as before with the flowers, I have my red flower, RR, because again, everything's still dominant. I've got my blue flower, BB. And this time, if I were to do that same cross that I did before, that ended up with BR, it would not be purple like it was last time. Instead, in this situation, it is going to be a flower that is both red and blue. It has both traits present. It is not really a new trait. Both of them are expressed. They're co-dominant. In blood typing, this was AB. AB is co-dominant. Both the antigens on the blood are there. Okay. And then you just looked at the crazy world of sex-linked traits. It's still dominant and recessive. So we're kind of back to normal. You have these guys back, except they're on the X or Y chromosome. So a little different situation. When you're doing the Punnett squares, and I'm just going to use the whole space here, you are always crossing a male with a female, which is why it says you always start with XX and XY, because you have to. You are using a male and a female. This is the male, this is the female. So if I were going to say that he is recessive and she's a carrier, then this would be the Punnett square, and you can put this information right there. This would be the Punnett square that I would be completing. So this would be hers, hers, his, and hers. So these are my boys right there. These are my girls. And instead of it being out of 25, because if they're going to say how many girls, how many boys, then it's going to change the game. It's going to make it out of 50%. Now, if they say offspring, you got to read carefully, then that's different. So we've got, pull this out here, so 50% of the girls are going to be normal, but they're carriers. See that? They're carriers, normal carriers. And we have 50% that have the trait, that are affected, whatever this trait is that I just made up. So that's the girls. The boys, you'll see the same thing. We have 50% that are normal. Here's one that's normal. Here's one that's affected. And there's only two, so then they're worth 50% each. And that was sex-linked traits. The traits are on the chromosome, so it's very important when you're doing these, you have to have the X and the Y. You can't just have the letters by themselves anymore. They're attached to the chromosomes. Okay, if you have any questions on these four, please ask before tomorrow. And yes, you get to use this. You're welcome.